yeah, I'm one of the engineers from Embedded LLM. So today the topic I would like to cover is like some important things that going on in vLLM, and then to introduce this new repository that's been out for like a month and plus already. But this time I'll go a bit details because I think this is the first time that we introduce this VM Omni in Thailand. Okay, so yeah. Now, a quick introduction about like what our company does. So basically, we are trying to create a federated network of like AI grids, so that you can utilize any kind of hardware. And this where like vLLM software and vLLM Omni, where you can run various LLM using almost any type of hardware resources that you have, from like NVIDIA, AMD, Intel, some Maker4, etc. Okay. So yeah, a quick recap. So I'm going to focus on the VM side. I'll go through like the two important things that's going on that's very crucial to like the VM framework that makes it fast. And then I'll go into VM Omni and then explain like what is VM Omni and then how is it made and then how you can use it on your own like existing infrastructure. So yeah, let me repeat again. So our goal is to build the fastest and easiest to use open source LLM inference engine. So I hope that you guys feel the same. Okay, so basically vLLM offers a huge ecosystems of like models, and you can run on various accelerators, and also it has been integrated into various frameworks from training till to production, like inferencing, large-scale inferencing. So the models that vLLM currently supports has been like hundreds of them. So all those famous models you have seen, you have heard recently, like Minimax 2.5, Kimi K2, etc., vLLM5, they are all supported on vLLM since day 0. And the accelerators, yeah, basically like I say, you can run vLLM itself on various hardware. So all this, yeah, even some of those that you might hardly heard of, they are there as well. IBM Spire, OSN, and like Maker4 surveillance. So vLLM has been widely used because, especially in RL, you need to unroll basically samples, your data point, etc. So that is the inferencing workload. So they have integrated this vLLM into their framework so that it speeds up the trainings. So like Unsloth, all this RL, yeah, they have been using vLLM as their inference engine. And also vLLM has been integrated into various like production stacks where you can manage vLLM instances as if like an infrastructure itself. So you can scale up, scale down vLLM instances based on your workload using Kubernetes, etc. And there are some works that try to further accelerate like vLLM by building on top of it. We use most of the components from vLLM, and to improve the performance further. Especially like LLM cache, they are basically hosting a shared KB cache memory pool in a like storage node, and then all other GPU server nodes, inference nodes, they are connected to that. So whenever there's a request being sent across different GPU nodes, and they will check whether there's a cache hit. If there's a cache hit, they can directly get it from a remote storage server. So rather than just only isolate the KB cache in a single GPU node, now it's shared. So basically there's more context sharing in this sense. So apart from that, like all those external libraries that I mentioned, they are not maintained within like their organization. They are used by third parties. But within vLLM ecosystem itself, we have offered all these like different things. I'll just give it through because there's a lot of details into it. You can like search it up later on. So vLLM Omni, later I'll explain what. And then vLLM recipe is where you find out about how to run certain models, like what configuration, what Python arguments, server arguments that the model provider or like some of those GPU vendors, like NeoCloud, etc., they might run some benchmark and then they will write down like what's the recommended settings. So you can find it all there. And vLLM basically is a tool that's help you to profile benchmark to get the Pareto's frontier line. So you can use that library to do that. And LLM compressor, as the name says, help you to compress LLM models. So they have provided various scripts. Even right now, also you can use it to compress like visual language model as well. And yeah, speculators. This is rarely heard, but basically this is a repository that helps you to quickly fine-tune like ego tree models on top of existing models, so that you can use the ego tree speculative decoding approaches to like accelerate the inference. So all the models that has been trained using this speculator, it will save into a file format that can be easily deployed using a vLLM framework. And this is a new one, basically semantic router. Basically, they have one orchestrator that figures out like which tasks should call which model, so that you can utilize the capability of different models, because different models can excel in different parts of the task. And sometimes you can also use this to control the cost. So basically what they found that by using this semantic router, they can reduce the cost of inferencing across multiple models. So you only call those like large models whenever you're trying to solve complex tasks, but simple like instruction or like say hi, you can just call like small models to process those requests. You don't need to waste the compute resource by invoking the large models. Now, so today I'm going to cover two important like frameworks optimization that vLLM has been basically pushing it as first-class support in their framework. Okay. So one of it is torch compile and fusion pass. So torch compile, I think basically is not that strange, not much of a stranger to you guys. So basically, we need to write kernels. We have to write mostly in C++. Like they are Python, Gluon here, etc. But you still need to you basically need to be an expert in the algorithm in order to like write a good kernel for your own models. So and it takes a lot of time. So what torch compile does is that it offers this capability where you can convert all those torch API that you call like torch.nn module, torch.function, like f.linear, and then later on you have a quantization function, etc. So they will optimize all those codes and generate like bytecode that are faster. So basically, they will figure out what ops that needs to be fused. So there's this notion that's called kernel op fusion. So in the later two slides, you will see like why using fuse op is faster. Okay. So basically, this is a rough sketch of like what torch compile does. So for the models that are written in PyTorch, you just need to add a decorator called torch compile, and then it will generate like this is sort of a representation, but they have a lower representation that's called bytecodes that are a bit more complex than this one. This is just an illustration. Yeah. So you will make sure that everything works. Not only compile, you also have it to add the CUDA graph support as well, enable together with it. And with that, when we create the graph, we have a graph of nodes, basically a description of how each ops being called. Okay. And in that graph, then we can do like fusion. Okay. Because PyTorch, they might have their own optimization, but as we know, LLM research is so fast that PyTorch hard to keep up. Like PyTorch releases a new version like maybe a few months once, so it's really hard to get those new kernels roll out. So in this case, then vLLM offers this called fusion pass. So we have a system where it allows to find certain patterns that the developer defined in vLLM, so that it tells the torch compile how to merge those nodes Okay, so for example, like currently we are trying to fuse this RNS norm to the with quantization kernel. In this case, it's a tensor quant. So someone has written a kernel that fuses this into a single kernel launch. So what in VN, what it will do is that it will fuse this and then replace this whole bunch of the code till the quantization over here with this operator. Yeah. So the reason why fusion of is right now is a very huge thing that's helping you to further push your inference speed is that it reduces like memory traffic, because after a kernel launch is being done, you need to actually store all those outputs into a global memory. So which means that after you call RNS norm, you need to store the output of RNS norm in a global VRAM, and then only load it again from the global memory into the L1 cache and register. So that's another like slowdown. So if you fuse all this in a single kernel launch, you can cut down all those like memory traffic. Yeah. So basically it's like this. You need to go DRAM and then again, so it's kind of slow. If you fuse everything, it will be very fast. And another thing is that launching kernels that's CPU overhead, so that also takes up time. Yeah. And besides, if you by writing a fuse kernel, you can make sure that you can design it in a way that better uses the cache as well. So basically, these are all the fundamental reasons that why fusion ops is become a thing, and we need to have this fusion pass in the VR. So currently it supports all these type of fusion ops already, and many more are coming out soon. Okay. To understand more about the torch compile, how it works, there's another VR post that you can go out and read it. Okay, and to use this feature is very simple. It's just VLLM serve like -03. It's just like in a compiler you specify -03. You uses the best level of optimization. Yeah, and everything will be enabled. Okay, so the second optimization point would be the async scheduling. So likewise, basically the whole framework, apart from just the model part, you still have the scheduler processing your requests that's at the API server layer. So all those things, basically they are CPU ops. So in order to maximize, we need to maximize the inference performance. We have to keep the GPU busy. So in a synchronous setting, your GPU, you see there's a huge gap here. So that's what usually the term we use like bubbles. So we have a huge GPU bubbles. So in vLLM, we have implemented this asynchronous scheduling where we allow us to like, when we're executing current step, we already started to prepare the metadata for the next steps, so that we keep the GPU utilization as high as possible. Yeah. And to enable it is just this like async scheduling. Yeah. So these are two major important features that for VLLM. And yeah, next I'm going to talk about the VLLM Omni. So what is Omni? So basically Omni describes about like various type of things. So in this Omni modality means like your models can process multiple types of inputs and generates multiple types of outputs. So in this case, like currently what we are supporting is like text, image, audio, video as input, and then you can generate text, image, audio, and video as output. Yeah. And actually this is very complex. So that's why we extend it in the external repo. We are not doing it in the vLLM repository. So basically, currently there's no single standard. Omni modalities are very complex and to define. And for now, there are three main types of Omni models architecture that we have supported. It's like all these three. So the first one will be the easiest one, just the diffusion model, like phone image. Okay, and then the middle one would be like some models like Bagel, so they have these like two different encoders and then one auto-regressive models, and then here you have your diffusion models. And this is like the Quant Omni model is very complex, so they have this like they call it tinker models that's trying to embed all this information like your text, your visuals, and the audio, and then start to generate. And then they have these things that try to convert the text into speech at the same time. So a rough, quick look. So vLLM Omni is built on top of vLLM. So most of the parts are the core parts are reused, like the entry point, the LLM engine executor, and then since like now we have need to schedule more stuff like for audio information. Okay, so that's why we are modifying the some of the components like the cache, the scheduler, and the runners. And since diffusion is something that's very new, it's not supported in the main repo. So basically, we implement the whole everything in this new repository. Yeah. So like I said, basically just now you look at the models, they have various stages. Okay. So how this is a high-level abstraction where it abstracts out regardless of the component. So how we make sure that we can pass various like hidden states from like the audio encoder into the LLM models, then into a code to wave that generates the audio. So we arrange them as a state, and then we are using a memory pool that's to transfer all these like KB cache or like hidden states between them. So this is also one of the part that's where optimization is very important. You might want to do a GPU to GPU transfer as well. Okay, so like for example in these Session3 models, so in the first stage you have a tinker model. So you send a request to it, it will process, and then you call this on stage ID 0, and then it will transfer this through the Omni connector, the hidden state Omni connector to the second stage, and then likewise, yeah. So that's how the whole process works in a vLLM Omni. So it's a more complex scheduling as compared to vLLM. So since we have this pipeline, same as in vLLM main repository, we also optimize it through like pipeline asynchronous streaming state so that we overlap as much as possible and reduces the gap between each request. So in this case, we can get a lot of like a huge gain as compared to just use transformers like yeah. And apart from that, like to reduce the response time, okay, of a certain request, in vLLM we have chunk preview. So likewise in vLLM Omni, we also need to like chunk our request as well. But this time the chunking involves a lot of different modalities. Like you need to chunk audio data, you need to chunk image data. So all these also have their own complexity, and we are almost there already. We have like still have I think 3 or 5 PRs. Still we have a full feature. Yeah, but right now when you run a Quant 2.5 Omni model, you can already get these benefits. I remember it's like 2x or 3x faster. It is a lot. So how you can get started? So basically, we have to make everything simple, just like in the vLLM repo. You can just like install it using like pip install, or you can use our preview Docker to launch it. Yeah. So you don't need to sell all the other like toolkits like CUDA, etc. Yeah. And for those who are going to like who are interested into like maybe use vLLM only in your own software stack, so there are few interfaces that you can call in your code. Like first of all would be this Omni class. It retains a very similar kind of API like the vLLM like LLM engine. So basically, you just create a LLM object, and then you can use like .generate, so that the API will retain it the same. And yeah, you can also host it with open API compatible server. And but this is just my experience though. Like most of the time when you have new models, like new features, usually we support it on the offline mode more first, because offline mode is easier. And the reason why there's a delay between the delay in supporting certain features on open API server is that currently there's no standard for omni-modality like output requests. So right now we are basically exploring and trying to refine to come out with a API schema that could accommodate like all kinds of models. Yeah. So yes, we have this, and yeah, to basically we also offer this scenario, offer this demo script that you can easily run and then try it on your like own desktop PC already. Yeah, we have this radio demo because it will be more fun if you have something that you can quickly like launch and then interact with it. Like it's a bit different from vLLM where you only have like text output, but now you can play around with like you can give it text and then you try to generate image, try to generate video, try to generate like audio as well. So you can like some of you guys are maybe some developers or like you have blog posts, etc. Now you can make enrich all those articles that you are trying to produce, or like maybe your PPTs as well. Yeah, you can basically start using like vLLM to help out with your presentation more as well. Yeah, it's really fun. I hope you guys try it out. Yeah, so we already support a lot of models right now. Yeah, and this is just like the beginning of like January. So now we have more. So yeah, feel free to try it out. Yeah, and these are the current accelerator supports. So that you can run the vLLM on. Okay, NVIDIA AMD MOSN and Intel GPU, which is like D60 supports is coming up. So Intel they are working on that. Yeah, so that's all basically. And yes, if there's any contribution, yeah, thank you so much for contributing to make this like community grow. And for those who haven't started contributing, feel free to join us on this community, because yeah, basically there's a lot of passionate like developers out there that would like they are very happy to interact and also like learn from one another. So basically, like I feel like, because I myself, I just feel like I'm from like Malaysia. I also like give some talks in Malaysia as well, and Singapore. Sometimes it's like we might feel like we are a bit far away from the community in the US or in the mainland like China. Okay, these two are the biggest like developer community group. But don't be afraid, like because on this platform, basically anyone can just ask any question and just like interact. So I think this is a very good platform to bridge to engage with all those international like AI developers, especially those who are managing a lot of infrastructure, who are deploying LLMs. They have a lot of experience over there. Yeah, so feel free to join the Slack channel. So VM Omni and vLLM, they share the same Slack. So basically, the whole community are basically the same one community. Okay. And we have a lot of blog posts as well. Yeah. So feel free to join. And that's all for my presentation today.
Okay, thank you so much for that. Our host has prepared you some gifts. Could you stand in the front? to take a souvenir picture together, please? Thank you. Thank you so much. So vLLM is a better way of enhancing the large language model or LLM we have today. Next up we have Play Pump.